Well, hey everybody, and welcome back to another episode of Bowmaths. Last time we talked about how to slide the number line around, and this kind of came about from us taking on what does it mean to have like a different perspective on addition, and we discussed different ways about which we could interpret the idea of addition. And one that we introduced was sliding the number line, not just taking a point on the number line and moving it around, but rather looking at the entire number line and how to kind of shift that around in space and how that would look. And so now to get more comfortable with this type of thinking, I've prepared some practice problems over here that we're going to try. So let's look at number one. Solve the following by shifting a number line. So all four of these parts involve adding 3, right? We have 3 plus 3, negative 2 plus 3, 1.5 plus 3, and 0 plus 3. And as we noted last time, shifting a number line will allow us to kind of do all of these in one step. So let's take a number line here and go about labeling it. Now, one thing that's important to learn is how to actually label a number line. You might think, hey, that's easy. Just do something like this, where you have numbers 0, 1, 2, 3, 4, right? And you just go in both directions. It should be the same every time. However, sometimes we want to label it differently, because if we look at the example here, we have a lot of negative numbers down here. But really, the lowest negative we go to in this problem is negative 2, which means that all of these are kind of unnecessary. Additionally, we have a 0.5 right there, 1.5. Now we could go between 1 and 2, right? 1.5 is around right there. However, that kind of maybe loses some accuracy because we're eyeballing where the halfway point is. So one thing that we can do is we're completely labeling the number line. We have total freedom over how we label it. And so what we can do is we can choose how far one point is to the next. For example, here I'm saying, okay, from one line to the next, it's 1. But there's nothing saying that I can't go from 0 to 10 to 20 to 30, or from 0 to 5 to 10 to 15, and so on and so forth. And also where we put it, right? I could put a 0 here, I could put my 0 down here. So we have freedom as to how we label our number lines in order to match the problem well. So what I'm going to do with this number line is I note, okay, we're going down to negative 2 at the lowest, so we don't really need to go much below that. So I'll just write negative 2 here. And to account for this 1.5, I'm going to go up in increments of a half. So the next step up wouldn't be negative 1, but rather negative 1.5. And then we get to negative 1, and then negative 0.5, and then 0, 0.5, 1, 1.5. So every single step, I'm just going up by a half, right? And that's because it's totally arbitrary how we label this number line. Ultimately, the number line is just a way in which we represent and visualize our numbers, right? So I'll just go along here, and that should do it. So again, I'm starting at negative 2. I don't need to have 0 at the center all the time because we're just kind of labeling this and using this as a tool to put the numbers in space. And yes, let's go ahead. So we have our number line here, and I'm going to make another copy of it as we did before. All right, so all of these, we've added 3. So what should we shift the number line by? Yeah, we should shift it up by 3. So to do that, we'll just slide it 3 units to the right. 1. But that's another thing to notice, actually. I almost made a mistake there. So I shifted it over 1, but the thing is, 1 unit now is actually only worth a half, right? So to actually shift it over a distance of 1, I'm going to have to shift it over from negative 2 to negative 1 like this, right? So that's actually 1, because if I shifted it over just like this, I'd actually be only moving a half. So that's one thing to keep in mind when we're labeling these. So I'm going to shift it over 1, 2, 3 units to the right. And we see that this should line up well because negative 2 goes to 1, because negative 2 plus 3 is 1. Negative 1 goes to 2, negative 1 plus 3 is 2, and so on and so forth. So now let's look at the numbers they want us to identify. We're looking at, in part A, 3 plus 3. So A was 3 plus 3. So that means we'll look at where 3 was. And what does that correspond with? That corresponds with 6. So we see that by shifting the number line, our 3 corresponds with 6, and we get that 3 plus 3 equals 6. Next up, negative 2 plus 3. So we look at negative 2. We added 3 by shifting the number line, so it's going to correspond with its answer of 1. So we get that negative 2 plus 3 equals 1. And then for C, now this is where we have a decimal involved. We have 1.5 plus 3. So we have 1.5 here. We added 3 to it by shifting the number line. And that got us to 4.5. So we have that 1.5 plus 3 has to equal 4.5. And for part D, 0 plus 3. Well, we start with 0. And remember, 0 is over here, but then we shifted the number line over by 3. And that will land us at 3. So via this technique, we see that 0 plus 3 equals 3. All right, perfect. So let's move on to the second one. Solve the following by shifting a number line. Same things before, but with different numbers now. 10 plus 20, negative 30 plus 20, and 15 plus 20. So in all of these, we see that once again, we're adding 20, so it's going to suffice to shift the number line by that amount. However, now we're seeing that we're dealing with a lot bigger numbers than before. And so it might be useful to label our number line accordingly. We don't actually have space to label these by halves or by ones anymore. We have to make these distances into bigger values to account for the bigger values in the problem. So I'll get another number line going here. So our smallest value is negative 30. So we're not going to go any below that. So I'm going to put negative 30 here. And we do have some things with 5s in it. So I'm going to go up by 5s. So I'll make another copy here. All right, great. So for this one, we're to look at 10 plus 20, negative 30 plus 20, and 15 plus 20. All right. So first of all, we have 10 here, and then negative 30 is down here, and then 15 is over here. And we're adding 20, which means we're going to be adding 20 to the entire number line, which means we're going to shift it over by 20. Now, to shift it over by 20 means that how many spaces are we going to go over? Well, each space goes over by 5. So to shift it over 20, we're going to be shifting 5, 10, 15, 20, right? Because we're going up by 5s each time. And we see that we went 20 units over because negative 30 plus 20 is indeed negative 10. And that's the first problem. So, or no, that's not the first problem, that's part B. So we can write that in ahead of time here. Negative 30 plus 20 is 10. Now let's return to 10 plus 20. So we see via moving the number line over 20, we get to 30, right? 10 plus 20, shift it over, lines up with 30. So that means 10 plus 20 has to be 30. And then we have 15 plus 20. Well, 15 was over here, just beside our 10. And that moved over to 35 once we shifted the number line over by 20. So what we're going to get here is 35. Now again, one thing to keep in mind, of course, it's much faster to just know that 3 plus 3 is 6, negative 2 plus 3 is 1, negative 30 plus 20 is negative 10, and so on. However, this is just giving us another perspective to take on what addition means. All right, so this next one is a word problem, and it's a little more complicated, and maybe it kind of gives some insight as to the importance of taking this perspective. So I'll go ahead and prepare that now. All right, so we have a 4-meter long car. I'm not a very good drawer. That's my car. All right, and it's 4 meters long. And it wants to park in a 4-meter long parking space. So this is also a 4-meter long parking space. All right. And the front of the car is 3 meters away from where the parking space begins. So this distance is 3 meters right in there. And one thing that's really important with the word problems is always kind of try and draw out a diagram when you can. It'll help you visualize the problem a lot easier. All right, so we have all the preliminary information. Now let's go to part A. By setting the end of the car to be at position 0 and the direction it's traveling in to be forward, use a number line to depict the situation. So what it's asking for us to do is to take a number line, and it wants us to kind of visualize the situation on the number line. Now it wants the end of the car to be at position 0. So that means it wants this back half of the car to start at 0. And remember, the car is 4 meters long. So that means the car is going to kind of occupy this space here. So this is the car. It's a very long car in this kind of drawing, but the car, as we see in this number line, is 4 meters long. All right, and it's starting at 0. And it says that it's traveling in the forward direction. So that means the car is moving this way, because generally forward refers to positive. So using number line to depict this situation, that's what we're doing, and we need to put the parking space in. So we know that the parking space starts 3 meters away from the car. So we're going to go 1, 2, 3 meters over. So this is where the parking space starts. And the parking space is 4 meters long. So we go 1, 2, 3, 4. So the parking space covers from 7 through 11. So this is our parking space right there. All right, so that was part A. We completely depicted what just the setup here. We have a car that's 4 meters long, starts at 0, parking space 4 meters long, and it's 3 meters away from where the car is. So part B says, what number do we have to add to the number line to ensure the car can park? And since our car is going to be what's moving, I'm going to draw the car on the number line. All right, so we know our car is 4 meters long. And now what we want to think of is, okay, how do we get the car into the parking space? Well, the car is going to need to move over like that, right? So it'll fit into the parking space. So what we can do here is that can be accomplished by moving the number line. So what do we need to move it by in order to get into the parking space? Well, we want the back end to be in the back end of the parking space. So that means we have to go from 0 to 7. So if we add 7 to this number line, it'll move it over by 7 units, and we will line up exactly with the parking space. So by adding 7, we've effectively kind of transformed the car's position to go into the parking space. And so this is kind of a way to think about this real-life movement, but kind of using number lines, where the parking space stays still relative to the car, but the car is moving. All right, so that was part B. Part C. If this entire situation was witnessed by a person 1 meter behind the car, how could we change the number line to include the witness such that they are observing from point 0? Okay, so this is an interesting one. So what it's saying is that we have a witness right here, a person who's watching the car, and they're watching the car move like this. So the witness is staying still, and they watch the car move. But we want to kind of reframe this situation to be from the point of view of the witness, where the witness is at 0 now. Because again, we can start, we define the car to be at 0 here, but it's arbitrary because we're just kind of placing a number line on this situation. In real life, there's not actually a number line there. So the question is asking, what would happen if we started with the person at 0 instead of the back of the car at 0? So let's consider that. All right, so here we have a number line with a person marked at 0. Ignore these scribbles, I just made some mistakes earlier. And what we'll consider is we're going to take our situation from before, where the car was lined up at 0, the back end of the car was lined up at 0. But now, if we add 1 to this number line, we're going to see that this person actually is going to be lined up with the observer now, right? So before, the person was at -1, but by adding 1, we've shifted everything over such that now the person is going to be at 0. And so redrawing this situation, the new car's location is going to be from 1 to 5. And the parking space's new location is going to be from 8 to 12. So just going over that one more time. Just in black here, we want the person at 0. But what we're starting with here is the situation where the car is at 0 and the person is 1 behind it, so at -1. So to move the person at 0, we have to add 1 to this number line, which will shift it up 1, which will give us a person here standing at 0. But what that'll do is it'll shift everything else accordingly. So bringing our perspective to the person at 0 will move everything over 1 as well. So the car moves up 1, putting our space not between 0 and 4, but between 1 and 5. And the parking space moves up 1, putting our space from 7-11 going into 8 to 12 now. That one's a little more complicated, so I encourage you to go back and think about it some more. Question 4. What would we add to the number line in order for it to not move at all? Well, if I take a number line here, and I take another number line, if I add 1 to this number line, it's going to move. If I add 3 to the number line, it's going to move, right? The only thing I can add to the number line that's not going to change anything is, what do you think? It's 0, right? Adding 0 does nothing to the number. 5 plus 0 is still 5. -3 plus 0 is still -3, right? Adding 0 does nothing. So we see that everything will still line up properly, right? If this is 0 here and this is 0 here and this is 0 here, then we'll know that, and this is 1 and this is 1, we'll know that adding 0 will do nothing, which means that 1 lines up with 1, 0 lines up with 0, and so on and so forth. So everything will work out well. So adding 0 is what doesn't do anything to the number line. All right, number 5, last one. Jack and Jill have 2 numbers. If I move the number line by Jack's number and then by Jill's number, it's the same as if I moved the number line over by 6. What can we say about Jack and Jill's numbers? All right, so I'll reuse these number lines here. Okay, so they start lining up, and just ignore these arrows for the time being. And it says that if we move the number line up by Jack's numbers, so that would move it up by some amount. We don't know what Jack's number is, though. And if we move it up by Jill's number, again, don't know what that is, it's the same as if we move the number line over by 6. So moving the number line over by 6, we know how to do that, right? We just move it up by 6. 1, 2, 3, 4, 5, 6, right? So we see that 0 corresponds to 6, 1 corresponds to 7. So we've effectively moved the number line over by 6. But we're saying that moving it by Jack's number and moving it by Jill's number is the same thing. So we know that essentially moving it by Jack's number would take us some amount, and Jill's number would take us the rest of the way such that it's moved over by 6. So if, for example, I took the number line and I moved it up by 1, and then I moved it up by 2 more, how many have I moved it in total? 3, right? But I did this in steps. I move it up by 1, that's adding 1. And then I move it up by 2 more, that's adding 2. But in total, that's the same thing as adding 3 to the number line, right? I moved it up by 1, and then by 2 more, that's the same as adding 3. And essentially what we did is we've combined these shifts by adding them, because ultimately shifting it is adding, and we can add multiple times. So we combine these into being one addition. All right, so now we're saying that moving it by Jack's amount and then moving it by Jill's amount ultimately takes us to moving it by 6. So what we can say then is that Jack's number plus Jill's number is going to have to equal 6, since the amount we moved it by Jack's and then the amount we moved it by Jill's number will ultimately be 6. And we know that from this example here that moving it by a set amount and then by another amount is the same as just moving it by the sum of those two amounts. So I hope these problems made sense to you. And if you want further practice, there's some things that you can do. I always encourage students to make up their own problems when they're practicing. And people might find that difficult or counterintuitive. How am I supposed to make up a problem when I don't fully feel comfortable with these topics yet? But sometimes it's just as easy as taking problems that you already have and just changing some of the numbers or changing the scenario a little bit. And I think this will really help you even understand the problems better because you will be not only solving problems, but having to think about the problems in such a way where you make them up yourself. Well, that's going to do it for me today. Good work. Have a good one. Stay groovy, and I'll see you in the next video.